Hi Geometry, this is our Unit 4 packet, page 1, and we're going to talk about Unit 4, Lesson 5, Intro to Trigonometry. When working with angles, we tend to use theta. It's a Greek symbol that looks like a circle with a line through the middle. We use other variables and other symbols, but we tend to use theta. And we have an acronym to help us remember our trig functions. It's SO, CA, TOA. And the SOH helps me remember that sine of theta is equal to the opposite side over the hypotenuse. That's my SO and H. The CA helps me remember that cosine theta is adjacent over hypotenuse. And the TOA helps me remember that tangent theta equals opposite over adjacent. This is the first three letters in my formula: T for tangent, O for opposite, A for adjacent. So this box has the same three equations I just wrote, and the words for SOHCAHTOA are identified right here to the side. So let's take a look at what it means to be opposite, adjacent, and hypotenuse. So let's take a look at this triangle mid-page. It would like us to find sine of A, cosine of A, and tangent of A, and express each as a ratio, a fraction, and then also as a decimal. So notice the top three all have an A in place of theta, and notice the bottom three all have a B. This is telling me which angle to look at. So for the first three, angle A is going to be the angle I'm focused on. So I'm going to label my triangle with my three sides based on A. Well, the opposite side is always opposite of A. It doesn't touch A. And then the adjacent side does touch A. And the way you can tell which side is the adjacent is go ahead and write down your hypotenuse. That'll be the one across from your right angle. The other side is your adjacent side. To be adjacent means to touch. Those are the three sides of my triangle, and those are the three sides used in my trig functions. So sine is opposite over hypotenuse. So let's go find my opposite side of A. That's the 5. I'm going to write the 5. And my hypotenuse is the 13. So sine is opposite over hypotenuse, or in this case, 5 over 13. On your calculator, divide 5 by 13, and you'll find that's equal to 0.385. Let's do cosine of A next. So cosine, look up above, cosine is adjacent over hypotenuse. So I'm going to enter my adjacent leg, which is 12, and my hypotenuse is 13. So cosine of A is the ratio 12 over 13, and it's a decimal. That's approximately 0.923. So finally, tangent of A. Tangent is opposite over adjacent. So let's go find our opposite. That was side 5, and our adjacent is the 12. And when I divide that, I get 0.417. So now to do the next three, you need to focus on angle B instead of A. Let's redraw the exact same triangle you see above. This is my A, this is B, this is C, this is the 5, this side's 13, and this side's 12. This time, I want B to be the angle I'm focused on. So I'm going to label my triangle based on B. So my 12 is now opposite. It's on the other side of my triangle from B and does not touch B. The 5 and 13 touch B, and I know the 13 is my hypotenuse. So that means the 5 then is my adjacent side. The adjacent side touches my angle. So pause this video for a moment and write your fraction ratios for sine B, cosine B, and tangent B. Use your calculator to get the decimal, and then come back to check your answer. Welcome back, Geometry. I hope you got the correct fractions and the correct decimals for our angle B. So I want to point out, I hope you noticed that the sine of B and the cosine of A is the same value, and the sine of A and the cosine of B are also the same value. There's also a relationship between my tangent. The tangent of A is really the reciprocal of tangent of B. So if you would do 1 divided by 4.17, you would get 2.14. If you would do the reciprocal of 2.14, 1 divided by 2.14, you would get 0.417. We'll be studying these relationships between the angles in a right triangle. A and B, angle A and angle B, are called the acute angles, and angle C is the right angle of our triangle. Angles A and B are also complementary. Angle A and angle B are complementary angles. That means that they add up to 90 degrees. Let's take a look at how to use sine and cosine and tangent to find values in my triangle. So let's take a look at our steps for using sine, cosine, and tangent. Step 1, always locate the angle that you're using. This is when in the last example we were either using A or we were using angle B. Label your sides opposite, adjacent, and hypotenuse based on your angle. And then determine whether you have sine, cosine, or tangent based on your labeled sides. Lastly, we're going to solve the equation for our unknown. So let's take a look at those 4 steps with example 1. In this problem, it says to find x. So first, locate your known angle. I know the 21-degree angle. So I'm going to mark my blue arc mark there, and I'm going to use that angle to do step 2. Let's label the sides. My side labeled x is opposite of the 21 degrees. My 12 is the hypotenuse. That makes my blank side my adjacent side. So now on step 3, you look at your triangle and you see what you're given. Well, I'm trying to find the opposite side and I'm given the hypotenuse. So now I think of my SOHCAHTOA and I'm trying to find something that uses opposite and hypotenuse. Opposite and hypotenuse look like it's sine. So it looks like I'm going to be using sine equation here. So let's write sine of 21 degrees, that's my angle, is equal to opposite over hypotenuse. Well, the opposite side is x, and my hypotenuse is 12. This is an equation. I'm now going to solve this equation for x. I'm going to multiply by 12 to get the 12s to cancel. I'm going to multiply by 12, and I find that 12 times the sine of 21 degrees is equal to x. So on our calculators, we'll find the sine of 21 degrees, we'll multiply by 12 and get x equals 4.3. Let's continue with this triangle. So step 1 is to identify your angle. So I'm going to identify my 42-degree angle as the angle I'm working with. So step 2, I'm going to label all my sides. Well, this would be the side opposite. The side labeled x is my hypotenuse, and the side that's 20 is my adjacent. So now I look at my sides for step 3, and I notice I'm trying to find the hypotenuse, and I'm told the adjacent. So I go back to my SOHCAHTOA, and I'm looking for something that has adjacent and hypotenuse. So I notice that cosine is A and H. Cosine is adjacent and hypotenuse. So I'm going to write a cosine equation. Cosine of 42 degrees equals my adjacent 20 over my x. So this problem, students can make mistakes on. Be careful. Your variable is in the denominator. This is all kinds of bad. You do not want your variable in the denominator. You need to get your variable out of the denominator. I'm going to multiply both sides by x. What about divide by 20? No, don't do it. You need to multiply both sides by x. This x is really over 1. My x's just canceled, and I have x times cosine of 42 degrees equals 20. I did that because now my x is in my numerator. My x is up and out of the denominator. However, I want to get it by itself. Let's divide the cosine 42 degrees to move it to the other side. The cosine cancels, and I get x equals 20 divided by the cosine of 42 degrees. I grab my calculator, I do 20 divided by cosine 42, and I find once I press equals, I get 26.91 for my side length. Hi Geometry, this is page 2 of our Unit 4 trig packet. Sometimes we want to find missing angles in a triangle. When we're given an angle, you saw on page 1, we used sine, cosine, or tangent to solve for missing sides. However, in a triangle, sometimes we want to find the angle. The angle is the missing part. So we're going to use sine inverse, cosine inverse, or tangent inverse. Notice I used the word inverse. I did not say tangent to the -1. This isn't tangent to a -1 exponent. It's tangent inverse. Those are two totally different things. And this is how I find missing angles. The steps are the same, however. We're first going to locate the missing angle we want to find. We're still going to label our sides opposite, adjacent, and hypotenuse in relationship to our angle. We're still going to determine whether we're going to use sine, cosine, or tangent using our SOH, CA, TOA. And then we're going to solve for our unknown angle. There should be an N here. Sorry about that. We're going to solve for our unknown angle, and we're going to use the inverse button on our calculator for this. And don't forget, your angles should be in degrees. So first of all, let's use our calculator to find the measure of angle T. So step 1, locate our missing angle. It's T. I could call this angle T. I could also use a theta here. I'm going to stick with T since that's what the question says. So step 2, I'm going to label my sides. Well, 29 is opposite of angle T. 34 is the hypotenuse of this triangle. And then the blank side is my adjacent side to angle T. So it looks like, as I'm looking at this, I've got opposite and hypotenuse. So I go to my SOH, TOA, and I realize opposite and hypotenuse are my sine. So I'm going to write my equation sine, and instead of writing an angle measure, I'm going to write t, or another variable such as theta or x or even y. But I don't know t, so I'm going to find t, that's my variable. It's equal to my opposite side, 29, over my hypotenuse, 34. So now I need to solve for t. I need to get rid of sine. You can't divide by sine, it's a function. I'm going to use my sine inverse. I'm going to take the sine inverse of sine. But if I do it to the left side, I'm going to have to take the sine inverse of 29 over 34. So sine inverse and sine cancel each other out, and I'm left with t. This is much the same way if you go back to quadratics and you have x squared equals 9, and I take the square root of both sides. The square root cancels the square, and I just get x. Sine inverse cancels my sine, and I just get my t. So t equals then sine inverse of 29 over 34. And just like we did sine, on your calculator, notice sine inverse is above your sine button. So use your second key to get to your sine inverse of 29 divided by 34 equals, I get 58.53 degrees for t. So here it says to use a calculator to find the measure of angle t to the nearest tenth. So let's take a look at 2 and 3 first. So on 2, I want to find the measure of angle t. T is here. In this problem, I'm going to call it theta, just to give you practice at seeing a variable there. So angle t, I don't know how many degrees it is, but it's theta degrees. That makes the 7 my side opposite. The 18 is across from my right angle, it's the hypotenuse. And my side adjacent that touches angle t is blank. So looking at this problem, opposite and hypotenuse, it looks like this is another sine problem. I'll write sine, and I could use the letter t, but in this case, I'm going to practice using theta. Theta is my variable. It's a variable for my angle degrees, is equal to 7 over 18. So I need to get the 7 over 18. I need to get the theta by itself. So I'm going to take the sine inverse of the left side, and I'm also going to take the sine inverse of the right side, and my sine inverse cancels my sine, and I get theta equals sine inverse of 7 over 18. By the way, this is not sine inverse times 7 over 18. Just like you would never say the square root of 4. You would never say square root times 4. Nobody would say that. You say the square root of 4. Sine inverse is the same way. You don't say sine inverse times 7 over 18. It's the sine inverse of 7 over 18. So on your calculators, second button, get your sine inverse of 7 over 18, and you get 22.88 or 22.9 degrees. It said to round to the nearest tenth, so I guess I went ahead and did that there. Why don't you try number 3 and then come back and check your answer. Hopefully you got 67 degrees for your answer. So let's take a look at number 1. Sometimes this appears complicated because of the radical, but it's just all in entering it in our calculators. So I'm going to call angle t theta again, and my 14 rad 3 is the opposite side. My 34 is the adjacent side because RT is my hypotenuse. So as I'm looking at this, I see that I have opposite and adjacent, O and A, and I realize that that is tangent. So I'm going to write tangent of theta equals opposite over adjacent. So I'm going to want to cancel tangent by doing tangent inverse on both sides. Not multiplying by it, doing tangent inverse to both sides. My tangent cancels, and I get theta equals tangent inverse of 14 square root of 3 over 34. So now this is all about putting this into your calculator correctly. So on your calculators with me right now, do 14 times the square root of 3 and hit equals. It's important that you get a number. you should be seeing 24.24 on your calculator. Now divide by 34 and hit equals again. You should have 0.173, so forth. And then now you would do tangent inverse to that number. If you're having any trouble entering it correctly into your calculator, come to office hours with your brand of calculator, and you and I will take a look at it together to make sure that you can enter your numbers correctly for the work that you have. And when you do this, you should get 35.5 degrees as your answer. So let's take a look at number 4. It says, what's the approximate angle A if the ratio of the adjacent leg divided by the hypotenuse is 0.54? Wow, okay. Let's see what they're talking about. The ratio of the adjacent over the hypotenuse. Adjacent over hypotenuse. Oh, wait a second. This is cosine. Adjacent over hypotenuse. So they're saying cosine of angle A is 0.54. The ratio of adjacent over opposite is 0.54. So that means the cosine of this angle A is 0.54. Okay, well, I can solve for this. I need to get rid of cosine on both sides. So let's do cosine inverse of the left side and cosine inverse of the right side. And my cosine inverse and cosine cancel. And I have angle A is equal to cosine inverse of 0.54. You need your calculator for that to calculate your inverse cosine. 0.54. We should get approximately 57.31 degrees. So try 5 and 6 on your own and then come back and check your answers. Welcome back, geometry. I'm hoping you got 72.1 degrees and 66.8 degrees. If you did not, very often this is a calculator input error. Can I also recommend, depending on which calculator you have, when you enter the 7 divided by 3 for the fraction, you hit equals. This equals is very important. Before you touch tangent inverse, if that's the order your calculator takes it in. I noticed that students have a calculator that writes tangent inverse on the screen, so they enter 7 divided by 3. They tend not to get errors on this type of problem. So if you understand your work, but you're not getting the correct angle answer, come to office hours with your calculator that you're using, and I'll help you get the right sequence of keystrokes on your calculator. Thank you so much.